We are ready, guys. Cell number 142 has been connected to the tester. All parameters have been set in the software and we can do the single cell capacity test. Guys, welcome back to the off-grid garage here in... It is already 10 p.m. but I've come back to the garage to start the capacity test on this cell 142 because it has failed 3 times before. Guys, I don't know what's going on, but the EB tester software is not running stable on this computer anymore for some reason. I cannot do a full charge, a full discharge and a full charge again. It somehow cuts out in the middle of that. So hopefully tonight we don't have these issues and we can see the final result tomorrow morning. Someone recently left a comment and said he wants to hear the music a bit longer, so I should stretch my intro a bit and stop cutting off these tunes all the time. So hence we had a bit of an extended intro today. So I have now once again programmed the Chinese cracker, the what's it called, the ZKE-Tech. It's the I think it's called the EBC A40L. Yes, correct. So tonight we are going to do a full charge with 40 amps to 3.65 volts with a 1 amp cutoff. This is how I test all my batteries. And then we do a full discharge with 40 amps down to 2.5 volts and measure the capacity. So hopefully in around 7 hours we will have the result. This will be at 5 a.m. in the morning. I will be still in bed. I probably make it until 7:30 tomorrow morning. Okay, without further ado, let's get started. Fully charge this battery. Shouldn't take much energy actually. Yeah, voltage is rising fast. 3.6 and... Alright, we hit the 1 amp and now we are discharging. 40 amps again and voltage is dropping fast now. And now we have to wait for around 7 hours to finish this test. So for now we do the full discharge test and measure the capacity until tomorrow morning. And until then, you have a good night's sleep. See you tomorrow morning, guys. So what do we see this morning? 299.1 ampere hour. Have a look if the program is still running. Yes, yes, it is fixed. The EB tester software is back. Well guys, welcome back and good morning. I hope you had a wonderful... Well, you didn't sleep at all? It was just 2 seconds for you. Duh. Oh well, we can see our beautiful discharge curve of the lithium iron phosphate battery number 142 in my pack. Here at the beginning we've got this steep drop of voltage down to 3.29 volts and then it stays flat all the way, and we are here at 3.2 volts still at 235 ampere hours. And then here further 3.1 volts. Here's 3.1 volts. We are at 283 ampere hours. And 3 volts is usually where I stop discharging my batteries here in my production system, in the battery shelf and the power wall. It still gives you a tiny amount of capacity left in case you need it, but usually 3 volts is a very defined spot on the steep area of the curve already. While here in this case, we have fully discharged the battery down to 2.5 volts to get the full capacity, which is 299.1 ampere hour or 964.88 watt hours. Almost 1 kilowatt hour of energy out of one cell. Nice. And going back to the cell information on the Gobelpower website, cell number 142 has been tested with 302.5 ampere hours at the Gobelpower factory. So why can we not see the 302 ampere hours in our test here? Well, the conditions are never the same. I can repeat this test here now with this battery cell and we will get very close to the 299.1 ampere hours again. If I give this battery to someone else and they use different equipment and the battery has maybe warmed up, because here in the off-grid garage in winter time it is fairly cold during the night, probably around 10 to 12 degrees only, so the battery may have only 15 degrees during discharging. And Gobelpower most likely has tested their batteries at 25 degrees Celsius. And even trying to replicate all the other tests they have done with the battery, I wouldn't bother, because I will not reach them. They could be over, they could be under, But hey, it's an EVE LF 280K battery with 280 ampere hour of capacity, and we get 299 ampere hours out of it. Should we complain? Not at all. Okay, my friends, I will now fully charge this battery again up to 3.6 test 40, 3.65, cut off 1 amp. That's what I'm doing. All right, you have a wonderful day. See you in a second. It's a bit of a mixed weather situation this morning, but the good thing is the EV tester software is fixed. It is still running. Good morning, guys. Welcome back. Well, I actually wanted to continue this video last night, but we had such a wonderful and beautiful day at the beach. We were actually running late, and then after a freshly baked wood-fired pizza and a beer, I was just too tired to come to the garage. I said, nah, let's wait until tomorrow morning, get a good night's sleep, start refreshed. And here we are. We have here the typical charge curve of a lithium iron phosphate battery, starting from 2.8 volts around. And then we start entering the flat part of the curve here at 20 ampere hours charging capacity already. 3.26 volts. Got a little bit of increase in voltage here, but then 3.34 charging voltage at 80 ampere hours. All the way to here, this is like 3.39 volt charging voltage, 260 ampere hours already. And if we zoom into this part here, we can actually see 3.4 volts, 3.45. This is the magic 3.45. And here we can see from 3.45 volts, the voltage is increasing a lot now, and it's going into the really steep part of the charge curve. And this is where you want to start balancing. Well, before, there's no difference here in cell voltages across the cells. And one cell could be still at 90% state of charge, while the other one is at 99% state of charge. They have the same 3.415 volts. There's no difference between these cells then at this voltage. So you really want to go over the 3.45 and even 3.4 volts. See how far back this is here? This is 3.4. Yeah, we're just seeing 3.4 volts here. And we are talking about charge voltage, right? If you have a sunny day, you can easily exceed 3.4 volt charge voltage for quite a while. And the balancer would kick in already and balance here in this still flat part of the curve and causes imbalance. So from our testing here on the channel, 3.45 is the magic number where you want to start balancing. And this is also the voltage where I stop charging, because we are already at 294.2 ampere hours at this voltage out of 298. Yeah, this is like 4 ampere hours. It's not worth stressing the battery cells by charging to a higher voltage, because there's no capacity gain. So 3.45 volts is the magic number to charge to and also start balancing. Then you balance basically only the cells which are going over 3.45 volts. They're getting pushed down from the balancer again, and then make them all conform at 3.45 volts. Perfect. And as I said before, I have already saved these curves, including screenshots, on my website. You can also download the EV Tester software and load these curves, and then do a right click on the curve and study which voltage you have at which capacity. It is all explained on the website, link down below. So anyway, we have now fully charged this battery cell number 142 again, and now we have to take away these 27.38 ampere hours again to bring it exactly to the same position where it was before, when we started all this testing here. Let me quickly explain. It is so because when we started all this testing here, all the batteries were at the same voltage and the same state of charge, right? So here it is. So when we started with all this testing, the battery was at around 90% state of charge, and to bring it up to 100% state of charge to 3.65 volts, it took exactly 27.38 ampere hours to do that. And now we've done all the testing, so we need to bring this battery, which is on 100% now, we need to bring it back down to 90%. So we need to take away these 27.38 ampere hours again from this state of charge down to there. And then we should be at the exact same point as we started before our testing. Yeah, so that's why I'm taking this away to bring the battery back to the same level as all the other batteries. Otherwise, we would have all the batteries sitting on 90% because we haven't used them, and just this one battery is on 100%, and we would have a huge imbalance, and we don't want that. So hence, we have to discharge with 27.38 ampere hours. It doesn't need to be 100%, you know, it's just we are getting the battery again to the same state of charge as it was before we started with all this testing. So that was the main purpose of this discharging 7.3 ampere hours. All right, so we can now remove the tester and assemble the battery again. I've got the bus bars here. Alright, so I have now connected the positive of the BMS and I hope it comes back to life. Yes, there it is. Nice. And as you could see, I have also torqued the terminals back to 7 Newton meters. I measured some of the other ones and they move at around 7 Newton meters, so I torqued them all with 7. So what I have not done is I have not connected the active balancer yet. So I left them both off because we want to connect the BMS first and have a look on the settings, how the overall cell consistency is. Because this is something Gobelpower advertises. So I plug in our RS232. I've got the pack information here, voltage, amps, state of charge, 80% it says. Ooh, I thought I charged it higher. But I may have used some of the energy already to do some other testing here, and this was the battery which was connected to the Powerwall 2.1 at the time. So it may take a while to fully charge the battery actually. 8 millivolt deviation we have. Let's have a look at the parameters. Read all. Ooh, I can already see they have changed it to 3.65 volts now. Thank you very much, Gobelpower. It is not sitting on 3.7 volts anymore. 145 alarm, 150 over current protection. This is for charging, and 200 amps discharging. We've got a balance start voltage of 3.45 volts. Balance deviation of 20 millivolt and a pack full charge voltage of 55.2 volts. 2 amp is our tail current and the low state of charge alarm sits on 5%. 58.4 volt pack voltage, 40 volt pack voltage on the lower end. Cell under voltage protection 2.7 volts. Well, we have to change this one to 2.5, don't we? Because we want to do a full discharge test. Charge under temperature protection at 0 and discharge under temperature protection at -20. Okay, so I'm not sure if they have actually modified exactly this BMS here because they send it to me and they know I like these settings, or if all the batteries come with these settings by default, which would be amazing. All right, it sits on Pylon Tech by default, but we can put the password 1, 2, 3, 4, 5, 6 in here, and we can change this one here to Victron, right, and just read it again. Yep, it's now sitting on Victron for the CAN communication. And you can see the amount of inverter it actually supports. 22 inverters just for the CAN communication. Wow. And here the list for supported inverters for people who are using RS485 communication to the inverter. That is another 20. Oh no, it's not 24. There are some numbers missing in between. Around 20. Still a lot. Alright guys, without further ado, let's connect this battery to our solar system here and charge it to 100% and see what happens without active balancer. But hey, so far I'm really impressed with the settings. If this is their default now and they deliver all the batteries with these settings here, I like it. It would be the first manufacturer who is actually listening to our wishes and prayers. How good are these terminals? I really like these protectors here because you can turn them around, can have one cable coming from the top, the other one comes from the bottom, and you cannot touch any of the terminals. They are fully isolated, and they are so easy to take off. That is such a good design. And of course M8. Perfect. And we've got 4 of them on this battery here for free. BMS is running. Turn on the circuit breaker, positive, negative. There we go. Turn on my solar production again. And we should see some sort of current coming in. 1 amp, 1.2 amps, 3 amps, 6 amps. Nice. 5 amps. Ah. Battery testing underway, right? And what do we have? Clouds. Of course we have got clouds. You can't win, guys. You can't win. This could take hours now to fully charge this battery. I probably use the power supply here and charge with additional 20 amps into the battery until it's almost full, and then we let the solar top it up. We had such a sunny morning. I can't believe it. Yeah, 7 amps. Okay, we cranked this all the way up to 21 amps, charging with another additional 1 kilowatt, 28 amps into the Gobelpower battery. It would still take 2 hours to fully charge. Damn it! By the way, the Seplos Polo batteries make a fantastic trolley for my power supply. Still super cloudy outside. I want to show you something. We are making 4 kilowatt from the DC system here on the garage and 712 watts from the tilt system. Isn't that amazing? That's why I like these clouds so much. It is insane how much power I'm getting. Just a very quick look here at the parameters again. 54.2 volts we have, charging with 27 amps, and we are at 82% state of charge. So voltage delta between all the cells is 23 millivolt at the moment. It's good. Okay, let's keep charging. Also interesting, when I read the capacity over here, it shows us a design capacity of 280 ampere hours, right? These are 280 ampere hour cells. So the full capacity, however, is 308 ampere hours. So I think this is very, very optimistic to get 308 ampere hours out of 280 ampere hours. So we will see. Guys, the sun came back in the afternoon and I have turned off our power supply, solely charging with solar. And we are approaching 54.5 volts with 25 amps charging. Deviation looks good, 30 millivolt only. So we charge to 55.2 volts. This is our maximum, our full charge voltage. And then it waits for the current to taper off to 2 amps. 55 volts we have reached. 41 millivolt deviation. We can see the internal BMS balancer is kicking in. And 55.3. Whoa, it's going a little bit over. And the current is tapering off now until we hit 2 amps. Where's my pool fence system? 1.7. We are under 2 amps. And now we are fully charged. Look at this. You can see it in the status here. Fully. We are fully, and charging has turned off. So charge MOSFETs turn off in the Pace BMS, but we are not touching the charge current limit. Look at this. It still sits on 145 amps. So that means if we introduce a load now, we will have the full power of our solar system available to power our load and not touching the battery at all. Even the charge MOSFETs have turned off. So the CCL here, the charge current limit, will only go down if we hit a protection status with any of the cells or the whole pack. Then it will tell the charge controller to slow down or to stop charging altogether. But reaching full charge does not limit our solar production, which is fantastic. Okay, so now the internal balancer will do its little bit. It balances with 50, 60 milliamps or something, but I have still turned off the active balancer for the moment because I wanted to see if we can reach the full charge voltage of 55.2 volts. So the Gobelpower website, as you remember, when we scan the QR code on the battery, it brings us to this specification page on their website, and this is specifically for my battery here. This is the serial number of my battery I have. And we can see they have tested this battery pack with 299 ampere hours and could also charge it to 56.98 volts, 57 volts, without hitting the 3.65 volts. And again, this is, you can see it under 0.5. Here are the test parameters. And you can see in number 5, This is without any active balancing. This is only how consistent and how matched these cells are for this pack. EVE LF280K B grade. They have a B stamped on the QR code. So in theory, with this setup now, we should be able to charge it to 57 volts without hitting 3.65 volts. Okay, let's try that. So if we go in here, go into our parameters, full charge voltage to 57 volts. Yeah, we write this back and let's see. We can see the current is ramping up to 21 amps, 55.7 we have. So we're charging to 57 volts now, and we watch the deviation here, and if one of the cells actually hits 3.65 volts. So deviation is going up, 56.6. Oh, which one comes first? Number 5 or our 57 volts? There we have 15.7 volts. And now we have several cells hitting the 3.5. This is just an alarm. There we go. We are now fully charged at 57 volts. Almost 100 millivolt deviation. And look at this. We can still see the charge current limit is on 145 amps. So turning on a load now will not deplete our battery. It will actually take the power from the PV charger. Well, what can I say? We have actually matched or even exceeded the test result Gobelpower has done with this battery here. We have reached a better result. I wonder how far we can go up until we see 3.65 volts now. What I have done is I have installed the small power supply here and set this one to 57.2 volts. Connected it to positive negative of the battery directly, so we are not protected with this one with the BMS anymore. So don't do this at home. This is just for testing purposes here in Uncle Andy's garage. This is nothing you can do at home, right? You always use a BMS when you charge your batteries, always. Promise. Good. And then we want to see when one of the cells hits actually 3.65 volts, which could be cell number 12. We are charging with 5 amps into the battery. The BMS doesn't show this anymore, but it shows us the voltage we have. 3.634, 3.64, 8, 7, 6, 5 millivolt, 3, 2, 1. Okay, that's it. 57.82 volts we have reached. So they promised the battery reaches 56.98 volts, and we have reached 57.8 volts until we hit 3.65 volts with the first cell. And again, this is without active balancer now. Shows the consistency and matched cells they have put into this battery. Okay, now we have 135 millivolt deviation. Let's connect the active balancer now. This side first, and then this side. Balancer is connected, the light is on, and we should actually see the deviation. Oh yeah, the deviation 132 millivolt. So now the active balancer is actually doing its work. So I have now set the power supply here to 58 volts, and we are still charging with 100 milliamps. And this is actually a very clever method to fully top balance your battery with a power supply and an active balancer. Increase the voltage slowly, give the balancer time to balance your battery pack, and over time it will be perfectly 100% fully top balanced. So buying a new battery, you would assume that the manufacturer of the battery would have fully top balanced your battery already. And Gobelpower probably did this, but they also had the balancer running all the time. And this imbalance, what we see now with 100 millivolt at 57.6 volts, has been caused by the balancer running all the time. And even in the flat part of this charge and discharge curves, it is doing some work. It is shifting milliamps back and forward and causing an imbalance. And this is exactly what we can see right now here. And that's why I'm not a big fan of having an active balancer connected all the time with lithium iron phosphate. You can do this with lead acid batteries and lithium ion batteries, no problem. But lithium iron phosphate, because of the flat curves, not possible. The balancer will actually destroy your top balancing. Well, Gobelpower actually gives you the option to upgrade your battery for a few dollars from this active balancer with the capacitors on it to a NEEY Active Balancer. Yes, I think it is $60 and they will put the NEEY Active Balancer in your battery instead of this Active Balancer. And I would 100% do this for this kind of money. You will have a NEEY, you will have app support for the NEEY, you can set your own balance start and balance stop voltage, and you will never have this problem again. And then even buying these cheaper B grade batteries with a B stamped on the QR code, they will always be fully top balanced at 58.4 volts. Yep, 100% possible with the NEEY Active Balancer. And when you discharge your battery, the Active Balancer will actually turn off at 3.4 volts, for example, lets you do your thing, and once the battery comes up over 3.45, it turns itself back on and does its job and balance and top balances your battery. This Active Balancer here is great, but it's not perfect. The NEEY is perfect. And here we can see our cell number 7 is actually over spec 3.664 volts. We've still got 96 millivolt deviation at 58 volts. When we have a look at the balance current here, it is 158 milliamps coming from cell number 7. This is how much the balancer takes energy, takes current away from this cell number 7 now, and puts it into other batteries which are in need of a bit more current. So now after around 20 minutes, maybe 25 minutes, I did something else in the garden. I came back, increased the voltage from time to time, and we are now at 58.2 volts. We are still charging with 400, 500 milliamps at the moment. And we can see cell number 15 is just at 3.65 volts. We've got 35 millivolt deviation, so I would consider this battery here as fully top balanced now and maximum charged. So this is the ideal condition now to do a full capacity discharge and see how much we get out of it. Because it says here we have 308 ampere hours available and remaining is 308 ampere hours. We want to confirm this, right? We want to test this out. And because we have been to the beach yesterday, so we did a 350 kilometer trip. I haven't charged the Tesla yesterday when we came home with about 60 kilometers of range. I think it was on 17%, so there's heaps of space on the Tesla to take the full capacity, all the energy this Gobelpower battery can deliver now. I'll set everything up now and then we get started. Okay, we are on 14% state of charge. All right, so 35 amps we are discharging. Okay, let's increase the power to 10 here. 45. Okay, let's go to 11. This is 50 amps, that's good. So we are in fact discharging with 51 amps now. This is probably the maximum I can get out of this adapter. So it is a bit less than 0.2 C at the moment, but once the voltage goes down from the battery, the amps actually go up to match the power the car needs. I've also just set 308 ampere hours in the Smart Shunt test. So it actually calculates a time of 6 hours and 29 minutes with this load. That will be after 8 p.m. tonight when this test is finished. Of course, it will be another late night show. I mean, come on. All right, you enjoy your dinner and we see us right afterwards again. Okay, so we are now discharging, or we are charging the vehicle with 11 amps now, but this is only a 10 amp circuit breaker here in this adapter box. So I hope it doesn't heat up too much. It should be fine. It should be fine to pull 11 amps for 5 or 6 hours. Oh, look how quick this flashes. The car is thirsty. Okay, quick snapshot of the deviation when we start the test and also the temperatures. There, you've got both. All right, my friends, it is already close to 9 p.m. The test is still going. We just dipped under 50 volt pack voltage, discharging with 55 volts, and we have a state of charge of 8% left. Down here we can see the deviation is at 35 millivolt, but it's slightly increasing now. It was on 25, 22, 25 all the time, but now we are at around 40, so it's slightly increasing. The cells are getting low and spreading apart now. The temperatures have almost not increased, but the current is not high enough for that. Even the BMS temperature is only at 27 degrees. Interesting, we have just consumed the 280 ampere hours, which is the designed capacity for these LF280K cells. Let's have a look in the history. We have pulled 14.5 kilowatt hours from this battery already. Wow. We are discharging for 5 hours and 21 minutes. Insane tests. And we have just reached the 290.5 ampere hours of discharged capacity. That is insane. Okay, I can already hear the fans are going slow in the inverter. So I guess we will have an inverter low voltage disconnect before we actually reach 2.5 volts with any of the cells. And 292 ampere hours discharged so far, which is exactly 15 kilowatt hours. Okay, we are at 44 volts. I'm not sure at what voltage the inverter will shut down. 165 millivolt deviation. But we are discharging with 43 amps only because the Tesla is now ramping down. It realizes the... Yeah, we can see here we have only 207 volts in the Tesla, and the vehicle now reduces the power it actually takes to charge. Under 43 volts now. 230 millivolt deviation. 294.3 ampere hours. 15.1 kilowatt hours so far. Wow. Okay, there it is. It is shutting down. 294.5 ampere hours. Oh no, we have actually a cell under voltage protection. Cell number 5 has disconnected our battery pack. And we can see the discharge MOSFETs are turned off now. So cell number 5 has hit the low state of charge, and we had a deviation of 290 millivolt at this stage. Oh no, I just realized I didn't have the screen recording running. Really? Are you f***ing kidding me? Oh wow, Andy. It is already too late, huh? I didn't click the button. I apologize for that. I didn't realize I have clicked on stop. Well, it is what it is. And interestingly, at 2.5 volts now, the whole BMS has shut down as well. So there's no power anymore to anything. You can see the whole link system has shut down, so there's nothing anymore. It is really protecting the battery now. So if we turn this one off, turn it back on. Oh yeah, this revives it. Yeah, and after 20 seconds or so, it turns off again. It's dead again. So what we can do now is we can now turn on one of the other batteries because they are almost fully charged. Maybe just the QSO battery because it's connected. And we should see. I think the protection has already kicked in here. Yeah, it's down to 20 amps current limiter. So it must have exceeded the 150 amps actually to charge the battery. And now it's limiting to 20 amps only. Fully charged, fully discharged battery in parallel and nothing happens. So we're charging with 23 amps only. Otherwise you could have charge currents of several hundreds of amps. Yeah, we can also see here the charge limiter is turned on now. Okay, we have reached close to 295 ampere hours with this battery during discharging. That is amazing and not expected from a 280 ampere hour battery. And Gobelpower has tested this battery here with 299 ampere hours. So we are only 4 ampere hours away with our own test here. And as I said before, test results do never match. If they test something and I test something, it will never be the same. So I'm not too concerned about this small difference between these test results. I'm actually more amazed that this battery actually delivers 295 ampere hours. It is an LF280K cell. How is this possible? And also, have we reached the 41.85 volts? Probably not, but we were very close. Yeah, I just have a look here in the history of the BMS. So we were at 42.1 volts and the claim was 41.85. So very close together. No big deal. Okay, my friends, so far this video from tonight, testing the Gobelpower battery here for capacity, cell and pack capacity. And I must really say, they have put together a fantastic battery. And if you have watched until here, Gobelpower still gives you a generous 12% off this battery here. All the information and links are down under the video. Some of you guys have already bought the batteries after the first video. You couldn't wait for the result of the capacity test, right? But now we've got this confirmed here as well. So I guess this battery has my full recommendation. I know it is not a do-it-yourself battery, but some people don't have time, they don't have the skills, not the tools to build their own battery, so they are on the market to buy one. And honestly, you can grab the do-it-yourself version of this battery for $2,500 US, minus the 12%. So with this, we are coming very, very close, if not cheaper, than building one yourself. The only thing I would really recommend is paying these extra $60 and get the NEEY Active Balancer installed instead of the capacitive balancer. And then I would say you've got the perfect battery. Okay guys, as always, thank you so much for watching. Thanks for all your great support here, for buying me a beer, all these wonderful and beautiful people who are donating to the channel here. Thank you very much for that. And until the next video, guys. Exactly, you stay charged, stay safe, and thanks again for watching. See you then, bye bye. There it is, the Gobelpower SR1 PC200B. This is the B version I have. There's also an A version, a B, and the do-it-yourself version. Got 3 all in total to choose from. All of them have 12% discount. At the moment, I should sell these batteries, right?